Good morning, guys. This is Mr. T and I'm going to guide you through the use of the Planck's equation in this station. So as you can see in this slide, Planck's equation is given by energy equals h, which is Planck's constant, times v, which represents the frequency. So the energy is always given in units of joules or J. Planck's constant is a constant and it's always the same, it never changes. It's 6.63 times 10 to the minus 34 in units of joules per second. And finally, the frequency, or V, is given in units of hertz or seconds to the minus 1, which is essentially the same thing. So whenever we are trying to solve problems that involve the use of Planck's equation, we have to remember what we learned in class about using this triangular tool that correlates all three variables, in this case with the energy on top, and then h and frequency at the bottom. So we have to ask ourselves, what are we trying to find? If we're trying to find the energy highlighted in red here in the triangle, then we have to look at what variables are left behind. In this case, Planck's constant h and the frequency v. As you can see in the triangle, they are both next to each other, and therefore that means that the energy equals h times v. On the other hand, if we're trying to find the frequency, if we look at the triangle in red, it's at the bottom. So we have to look at the variables left behind, in this case, energy and h, and we can see in the triangle that the energy is on top of h. Therefore, the resulting equation is frequency equals E over h. Now let's look at a concrete example. The example reads, the energy of a photon is 2.09 times 10 to the minus 18 joules. What is its frequency? So again, the first thing that we have to keep in mind is the triangular shape that we learned in class, and also that Planck's constant is always going to be 6.63 times 10 to the minus 34, even if that's not given in the problem itself. Remember that Planck's constant is a constant, and as such it never changes. It's always the same value. So knowing these two things, now we have to look at the problem and ask ourselves, what are we trying to find? In this case, the problem is asking us to find the frequency, and therefore, looking at the triangle in red, we have the frequency. Now we have also to look at the problem to see what else do we know. We also know by the problem that the energy of the photon is 2.09 times 10 to the minus 18 joules. In the triangle, that's represented by E. So now we know that we have the energy given by the problem and Planck's constant, which is always the same. All we have to do now is use the triangle as we saw before and use the appropriate equation to find the frequency. In this case, looking at the triangle, frequency equals E over h. All that's left is to plug the numbers into the variables, and then we have that frequency V equals 2.09 times 10 to the minus 18 joules, representing the energy, divided by Planck's constant, 6.63 times 10 to the minus 34 joules per second. The next step is to cancel any units that we can, and in this case we have joules both on top and at the bottom of the equation, so they can be cancelled. And then all that's left is to use our calculators to get a result. The result is going to be given in terms of 1 over second or hertz, which is the same thing. And as you can see here, the result is expressed with 3 significant figures because the energy was also expressed with 3 significant figures. Remember that constants don't count when it comes to counting significant figures.